Welcome everyone to our workshop. We're really happy that you're joining us. And this is a collaboration of three companies. And we're going to talk about real-time analytics. In this case, we're gonna um, do a pizza shop orders analytics, and for which we're going to use Bytewax. And I am from Bytewax myself. I do developer relations for Bytewax. I'm joined by Zander Matheson. Hey, Zander.
Hi, everyone.
Yeah.
I'm
Okay.
Zander. I'll be
Yeah.
speaking later. Thank you.
Okay. Then we have Viktor from Startree. Viktor, where you are? You were moving around. Yeah, here you are. Yeah, so Viktor will be covering the Apache Pinot part, which we're going to use for doing the analytic itself. Yeah, Bytewax was for some streaming, joins, etc. And each of the instructors will, of course, talk in detail about their parts. And then we have Caroline from Streamlit.
Super excited to be here. I'm Caroline. I'm from Streamlit.
Yeah, so I'm gonna post a link here in the chat so that everyone can see the GitHub repo, which we're gonna use during this workshop. Then I encourage you to join our Slack for asking questions there and for us answering. You can also use the Zoom chat as well, but I think for uh, uh, this one is going to be done after the workshop, and the Slack one is going to be there even if you have to leave earlier or want to follow with your own pace and have questions later. Just feel free to use this bit.ly link. It has all the other helpful links listed. First, I want to talk a little bit about what we're building here today so that you have an idea, and then we'll move to each of the instructors, and we're going to start talking about the building pieces of this application. So like I said before, we are doing the streaming real-time analytics of the pizza shop. So I have I pulled out the repo on my machine, so now I hope you see my screen, and please message me if you cannot see that. Well, I don't see the chat. Yeah. Oh, okay. Yeah, we can see it. All right. So here I just run the make command. So if you check out the repo, you would be able to do the same and see all the things being downloaded and then running the Docker containers and everything. And then we have access to watch what's going on. So we are generating some orders, data about orders and the products. And I use the Red Panda console to kind of look at topics. This is the common products. Yeah, and you can see the JSON. There is a name, description, price, ID, and like other items. Then there are products. These are also have like similar an image, and then there are enriched orders. So Bytewax part is to enrich the orders with the additional information from the topics of the products. So here we can see for each of them. Then all this information about the enriched products and the orders is sent to the Apache Pinot, and we can see them here too, running all smoothly. And we have a few examples of different commands that or like SQL requests that we can run. They're under the demo folder in commands MD, but that's just for you testing and playing with the code in case you didn't like want to run something. You just copy that conveniently into the query console. Yeah, here, and then the run the query. Something happened. Or maybe that's not the table. What am I using?
Yeah, you just use the different
Yeah.
one. You use the
Yeah,
query
I use a different one.
from MySQL.
Yes, I figured because we saved the users in MySQL.
You
Yeah.
can go into the screen
let me
and
see
you will see the
this. Yeah.
tables. Yep.
Yeah, so this one, for example. Yeah, this one was from MySQL. Sorry. Yeah. So on GitHub, actually, you can see the architecture. Yeah, I should have started here. So we have the make it bigger. We have the order service with orders, which sends the information to the Kafka topic, and then Bytewax enriches and combines the information from MySQL about the products, writes it down to the enriched orders topics in Kafka, and then Pinot analyzes everything, and we see the results on the Streamlit, which is the last part, and here it's like live dashboard with some statistics about the latest orders, most popular categories, and most popular items with pictures and whatnot. So while it's a very complicated hello world, as Viktor said before.
It's complex. It's not complicated. There's nothing complicated here. It's really complex. There's a lot of moving parts.
Yeah, so I'm really excited about going into like each of the part of this moving mechanism because there are a lot of use cases for each of the parts, and hopefully you'll learn something useful today. So with this, I'm gonna pass my mic to Zander, who's gonna talk about the Bytewax part first. Thanks.
Just a quick reminder for our speakers, if you have a chance to make your phones bigger, that would be huge help for many viewers. The easiest thing to check if your phone big enough is just like watch your Zoom meeting on the phone. So that's how I test like if my phones are big enough, if I can see them on the phone, that will work.
Victor, did you want to do the Kafka part first,
Yeah.
or should I jump into? Okay.
Yeah, just a quick thing that why we need all the things, and I'll just go ahead and share my screen. So I don't know if many of you have seen this diagram, but this is something that it's inside this repository. If you go there, you will see this. And idea is that why we need to have so many moving parts, because modern architecture require modern stack. And usually you not exposing your operational data store directly to users. You need to put something in front. You have some application that will be validating user input, or maybe some sort of like API gateway, or maybe something that's also called as a kind of event gateway. So in this case, everything that happens with your application, the users created new orders, people clicking around, or maybe your backend or like a back office people will doing something. Those things will not be written directly into your operational store. They might go into some sort of like event store. And in this particular case, we use Kafka because Kafka, it is a de facto system that allows to, first of all, be the point of integration between system. It can be event stores for different use cases. And I don't want to be like a very purist about the event-driven systems and how the Kafka is not suitable for this. For this use case, Kafka will capture two things. It's going to be capture the orders that our users are creating on the website. So, for example, they go into some REST service, and these orders that they click in on the website will go into Kafka topic. And the things what I was mentioned about operational store, we do have imaginary legacy system that has information about the products. Maybe some people on the back office will be reading data or like filling data through some sort of system. And the Kafka system has capabilities to capture these changes that happened in the database or query database directly. So there's both pull and push type of queries are supported. And this is where we go in everything in. And this is the next thing where we're going to be getting the orders information. We want to have like a tiny events that only include information about the IDs of these orders, IDs of products. And in order to run some sort of like our analytical queries, we need to enrich those with data that available on our like operational data store. So in this case, we also bring in the products into from the Kafka topic. And Bytewax as a technology that allows us to perform a logic of enrichment. Also, I'm specifically don't want to call this join because this is essentially what the enrichment is. We have a data in one format, we join with data in another format, but I don't want to create, because the word join in the world of data system is very loaded. And a lot of people have a different opinion. So that's why we use the term enrichment, because in this particular case, we will do like some sort of form of and actually, this is the place where the Zander will take over, because he also educated me about some of the ideas in the uh, and the vocabulary and the nomenclature that Bytewax has. Maybe it's not 100% would be aligned with the tools that I use in the past. In the past, in the Kafka Streams, for example, world, we use the concept of tables, and we materialize products into tables and do joins of the tables and stream. And Zander will explain the things with the stream processing in Bytewax much better. So with the, I don't know how many of you use Kafka before. Kafka is a system that is very open source, battle tested. There's plenty of providers who can provide you with the managed service. In our case, we're running this inside a the Docker Compose, but you can run this in cloud, you can run this everywhere. So the question, audio is good and volume is very low. Is it only Harry that complaining with the quality of audio, or like the volume of, or everyone also feel that my audio is too low?
Fine for
Okay,
me.
I can bump again a bit. Let's see if it works. We're good. Perfect. All right. And the I don't use the Zoom to control my settings, so I don't think Zoom is controlling my my
I don't think it's on your side, Victor.
yeah.
I can hear
Yeah.
you clearly.
Perfect. So another question. So Bytewax is not a ETL service. It is not entirely ETL service, and it's probably responsible only for T part, right, Zander? Let me unmute Zander.
Yeah, I'll get into what Bytewax
Yep.
is in a second, so I can
So
answer
in this
that.
model, using Kafka as a PubSub service to manage event forwarding. So, well, you can feels like it's a little bit oversimplification here. To quote to quote Barry Allen from the Justice League, it is not that pops up in the sense of it's not like a messaging system, though Kafka has some sort of the features that can be used in the pops up use case. Kafka used in this particular case in two modes. First one, Kafka works as a, what I called like event gateway. So our order service will essentially publish messages inside the Kafka orders. Think about this. It's a kind of continuous append only log of files. It can be used as a PubSub emulation, but essentially it is also durable storage. In the PubSub fashion, when the events come in, you usually don't have durability. And for the products aspect of this, Kafka acts as a kind of change data capture. So the events that happen on database will be captured from database and also written into Kafka. I don't know if it makes more sense or I make the things a little bit more complicated. And Kafka is source of truth. So all the data lands to Kafka, and we will be using Kafka next to do the things. We'll pass this now to Zander so he can talk a little bit more about Bytewax, and I will come back with some other things later this workshop. All right, Zander, you up?
Okay, cool. Thanks, Victor. So I'm going to talk a little bit more about real-time analytics and a little bit about stream processing, and then we'll start you on the journey to running this thing yourself. So my part here is part 2 of how we can serve up the freshest data. I've got a couple slides to kick us off here. So this is me. As you have heard, you have 3 chefs today. This is me in the middle, Zander. I work at Bytewax. And I happen to have a couple pizza jokes too. So why was the pizzeria desperate for business? Because they needed dough. What's the difference between a good pizza joke and a bad one? The delivery. All right, let's move along here. It's enough of that. So I'm Zander. I work on Bytewax. I love your support. There's a few people from the community here. Thank you for coming. You can check out Bytewax on home, Bytewax/Bytewax. I like pizza. I happen to like pizza. I'm not crazy like some of those pizza haters out there, and I'm a sucker for. It's unfortunate I have to say this out loud, but for Detroit style pizza, there's something about that like crunchy, but also gooey, and all the cheese and like the oil goes around, and it's so good. It makes me so hungry. Feel free to share your favorites if you want. So today's part 2 agenda, we're going to first talk about real-time analytics. You have my lens that I'll give you to understand real-time analytics. So this part makes a little more sense. Then we're going to talk about the slices of the RTA system and see what I did there. And then we're going to talk about stream processing, which is one slice of the pie. One more. And then we're going to talk about how Bytewax keeps things fresh. And then we're going to go out and search some pizza to eat, or I will at least. So in the world of data, what does real time mean? It means that the data is available for use as soon as it is generated. The data is processed immediately, and the data is made available to the consumer post-processing. And all of this happens in a low latent real-time manner. And that's why the architecture gets so complex, is because as an order is available, we need to be able to query it. And we can't necessarily query it from that operational data store. So now if we sprinkle some analytics toppings on top of that, the data is queryable at the moment it's generated. So that's where the complexity lies. Is like we need to be able to query the current and the most current and the historical data the moment that most current data is generated. So what is real-time analytics versus normal analytics? Well, here on the left-hand side, you have your regular day-old analytics. It looks pretty gross, right? And then on the right-hand side, you have fresh, beautiful real-time analytics. So do you want to hear another pizza joke? Never mind, it's too cheesy. So for our pizza orders, we want to serve up the hottest analytics made up with only the freshest data. I know if you're like me, you're also already drooling. So we already saw an architecture diagram. I'm going to break it down into a little bit of a different diagram that might be easier for understanding this portion of it. We have data generated from systems, whether they be real or virtual or physical or virtual. That data is collected, transformed, transported, put into a data store that is then queryable. And that all happens, in the realm of milliseconds. So you might be asking yourself, as many people do, who aren't familiar with why real-time OLAP exists, if I already have a real-time OLAP database that I can shove data into from various different sources like Kafka, why do I need a stream processor? And so how does Bytewax fit into this? So back on our earlier slide, we made it clear that we want our data available immediately for consumption at a really low latency. And so in order for us to be able to have a low latency query, we can't actually make joins at query time. And so, or enrichments at query time. So generally where a stream processor comes into the picture is in that transform and transport side. You want to enrich that data or join data together so that the query is relatively straightforward. Real-time OLAP systems are really fast at doing select stars. They're not really fast at doing select stars across a bunch of things they've joined together. So I'll introduce you to Bytewax. It's not an ETL orchestrator. Bytewax is an open source Python stream processor. So it provides a Python native API where you can leverage the Python ecosystem to build real-time applications. It was built for supporting more operational real-time workloads. It's based on top of a performant Rust engine that's called Timely Data Flow. You can do the stateful things you need to generally do with stream processors to make sense of a stream of data, which is windowing, aggregating, joining, connecting different systems together. We have a platform commercial offering that provides a lot of operational capabilities on top of Bytewax, and that's available. And we actually recently just launched an AWS Marketplace offering. So that's a lot of the DevOps light part of it. Bytewax is scalable and cloud native. And then it has everything you need to run in production, which is when you go down, you're not going to lose state. There's recovery built in, and we'll talk a little bit more about state in a second. So back to my simplified real-time analytics architecture. Here we're looking at this should say part 2. I got mixed up with the parts, but this we're going to look at is the collect, transform, transport part. And then to do that, we're going to make what's called a data flow in Bytewax. In Bytewax, a data flow is synonymous with a workload or a service. Say you're making a web service, you can kind of think of it in the same way. So as was described in that larger diagram, we have orders that are being sent through to our Kafka cluster on an orders topic. So we have orders coming in, and that order is going to have a lot of items in it. And the order is just going to be an order number, maybe when it happened, how much they paid in total, and then a list of IDs, and those IDs are all the products. And so what we want to do is enrich that information, that order. We want to take that order, we want to expand that list of items, grab those IDs, match the product information to them, and then we can send them down into an enriched topic. And so that's what we're doing in Bytewax, because if we were to do that, I mean, some of this is a little bit stretching, but if we were to do that in a real-time system, the join or the enrichment that would be required, which would be a join in the database, would be too slow to happen and be seemingly real-time. So that's what we're going to do. One more joke before we get started. Why did the hipster burn his mouth while eating his pizza? Anybody? Anybody? Because he ate it before it was cool. Get it? Because hipsters do things before it's cool. Okay. All right, on to the code. So I'm going to shift over here to VS Code, and we're going to walk through steps on getting started. So for this part of the workshop,
Can you do font a little bit bigger?
Font a little bit bigger. Now we're talking. Big enough?
Folks, let us know if it's the big enough. I have a big screen, so I don't complain. So I was wondering if people watching on the phone, so they happy. And also you probably can just like to close the terminal window for now.
Yeah, I'm actually going to use the terminal window in one
Oh,
second
okay.
here. So this part you can follow along if you want. I cut out a section, and now we're going to run that on its own so that we can see how it works. So one of the things that we wanted Bytewax to be able to do that's hard to do with most stream processors is just test things locally and run things locally. So Bytewax is really easy to get started. If you're following along make sure you have already cloned the repo. If you haven't, I'll just give folks a half second to do that. If I don't know where the chat window is, otherwise I'd point to the repo one more time. Okay, I'm assuming everyone has at this point cloned the repo, and then you should cd into the enrichment-bytewax part of the repository. So now we can pip install the requirements file, and this will install Bytewax amongst some other things that we're going to use. I already have them installed in this environment. I guess I should mention that.
While it downloads internet, folks, write down in the chat what kind of like primarily language you use for your programming stuff. We make assumptions about the Python and data, kind of like a Go as the cheese and tomato sauce. Also trying to keep up with the Zander's joke. I don't know, like trying to improvise. But yeah, like what's the primarily programming language you guys using? Nice, Python. Cool.
So you have two in the enrichment directory. You have two Python files. One is dataflow.py, so that's the one that will run in the Docker compose that you'll run later, and the other one is dataflowpre.py. So dataflowpre.py is the one where we're going to create this sort of testing apparatus. So I made a data folder in the directory, and in that data folder there's a generate.py, and that generate.py will just generate randomly some orders. I also saved the orders.json lines in there so we can use that. So if you want to go look at what the orders look like, we have the order ID, the created at, the user ID, a price, and then the items. And so the items, this is our issue we have with the thing. We're not going to be able to know that much of what's going on because we just have a list of product IDs, quantities, and the prices. And so that's what we're going to be enriching with the information contained in this here, which is the list of products that are currently available from our store. So in the overall architecture diagram, that was shown as two topics. For this instance, what we're actually going to do is just load this into memory, and we're going to enrich it locally. So let's walk through data pre. Now you all have Bytewax pip installed, and I'm going to move my terminal down here so it's small. Man, my computer is struggling right now. Okay, so we can ignore these two data classes. They're basically the product and the product and the orders as data classes. Okay, so let's get on to the data flow. Oh, wait, there's one more joke. A pizza walks into a bar and orders a drink. The bartender says, "Sorry, we don't serve food here." Lol. Okay, so to start any data flow, you start with a data flow object. So you can think of a data flow as a directed graph of processing steps. And so we create this data flow object, and then we're going to add steps to it. And after each step, we're going to be returned a stream handle. And we'll use that stream handle for each new step. And this is designed this way so you can have multiple inputs. So we could have input 1 and input 2, and we can have separate streams from input 1 and input 2, and then we could join them below. This is actually a pretty straightforward data flow. We're going to have a single input, and we're mocking what will come out of Kafka by opening this JSON lines and just reading them in one by one. So that's our mock orders coming in. The orders have a list inside them. So we're using what's called flat map. If you're from the world of Python like me, flat map is not so commonly used in Python, but it's essentially going to take a list and split it into single objects that we'll be using downstream. So we're going to take that list of items that you saw in orders.json load, and we're going to send those downstream one by one. Now we're doing some fun that we can do because we're using Python, which is we'll just load something into like global space, memory space of Python, and then we can use those products in an enriched step. So we load the products here from products.json lines, simulating as if we were to take those all from Kafka, or if we were to make a query from the database. And then we run a simple enrichment using a Lambda function here. So in a So these, I should have explained this, sorry. Bytewax has a concept of operators. So operators are essentially the things that control flow through the data flow. And that's why in flat map, we're splitting the items. In map, we're doing one by one. If we used a window operator, we would be batching things into a size session or other type of window. And so that's what the operators are used for. So we have a map operator, very straightforward, one item in, one item out. Operators are passed an identification string, this stream that we're going to operate on, and then a function. There can be more or less, but no, not less, but there can be more items. But for this type of operator, it's just these three. So we're passing in a lambda function here, where we're actually calling another function with the products and the order. So this enables us to pass that product object into the order. So we can go look at what we're doing in this first function. It's nice because, I mean, part of the reason we developed Bytewax is to be able to pass arbitrary Python functions into streams. That's kind of why it exists. So we have a regular Python function here that we're going to dump in. It's enriching the items, and all we are doing here is taking the product ID and adding in the product information, and we're taking that and then we're serializing it into JSON string that we would then put back into the Kafka enrichment topic. So that's it. That's all the excitement of the data flow. It's not so crazy. Then we have a standard out here. So everyone who's following along, we can run this thing. So Bytewax has a run module. If you're familiar with, I mean, old school Streamlit maybe, but not current Streamlit, or Flask or Fast API, you run it as a module. So in Python, this is how you can run modules. Probably everyone already knows this, and I'm just telling them useless information. And then you provide it with the actual data flow file, which is data flow pre. And then you can specify, just like when you use like Flask and you specify the app or whatever, you can specify that data flow object in here, which ours is called flow. You don't need this. It's going to look for flow anyway. But this is how you would run your data flow. And hopefully, you know, demo gods are on my side. And you see a bunch of amazing pizza orders of like amazing products coming out here. Crinkle fries, all sorts of good stuff. So that's it. And then now we have something that we could run as a test. So whenever we change this, I can't even describe to you how hard my computer is struggling. I still have an Intel-based Mac. I think I need to upgrade.
You definitely need to upgrade.
Yeah.
Because you're running at least like multiple services in Docker, so definitely.
I'm not running anything in Docker right now. This is.
Okay. So in this case, Google Chrome and Visual Studio Code.
Yeah,
That's, you know.
Yeah.
Props to JavaScript folks here.
I'm a CEO now, so I don't do anything real. I just do like administrative tasks. So I just have a bunch of tabs open for administrative tasks. Okay. All right. So at some point we turn this into our test suite. So whenever we modify the data flow, we can run those tests, which is really nice because we can run it locally. So the next step is, how does this fit into the broader ecosystem? And so the only thing we actually have to change is that bit about input and output. And so we have written a number of input and output connectors. For Kafka is one of them because that's the most commonly used system. So the code here is changed from Dataflow pre to have a different input, which uses the Kafka input. So Kafka has its own input and operators because there's some special stuff we've made to sync with the schema registry. So we changed the input here to use the brokers topics and use this Kafka input. And then we also have changed that little bit of JSON serialization that happened in the enrich mint part to a Kafka sync message. And so that's where you can like provide key value, header information, etc. And then we use the Kafka. Oh my goodness. 1 second. There we go. The Kafka output instead of the output operator where we were using standard output. We use the Kafka output operator, and we provide the broker address and the topic address as well. So that's all we have to do to change that to use it with Kafka. which is kind of nice. That's all I had to say. I don't have any more jokes, actually. That's the end of the joke. So I'm going to stop sharing my screen. You will run this file with the Docker compose. And I'm going to check if are any questions, because I haven't been looking at the questions at all.
That's a very interesting question. Is there a more efficient way than having two files with the same logic? I'm not following, JD. If you can
Yeah, so I
update.
think you could like have some sort of try or something. You could have some logic in there, or you could have you could steal from like from Flask or etc., where you could have a environment variable, and then basically um, swap the input and output you use based on the environment variable.
What
But
was
for
the
this purposes,
the kind of like a background to this question? I probably missed that, or maybe it's like
There are two
what was
files, data flow and data flow.
yeah.
Right.
So I
So
did it as
that's
two
the question.
files, data flow pre, which I would probably put inside of a test if I wanted to keep it that way, and then data flow. And the question was, can I have those just as one file and still do the local and the remote?
right?
And my answer was, there's no built-in way with Bytewax, but you could use an environment variable or some sort of configuration, and you would have both input mechanisms inside, and you would change depending on the environment variable, like for the Python developers out there, like you do with Flask and Fast API.
And I think this is the person I would put this in the test. So in this case, like in memory stuff that will be run without everything. But if you would for people who looking into what is going on with the code inside each component of this, the Bytewax, for example, component, it has its own like a Docker file. Everything is Dockerized, so you can see here. We're using the Dataflow Pi because we relied on integrating with the other bits of the system where we connect to enrichment. We're getting information how we can connect to Kafka, what's the input, what's the output topic, and the enrich the output topic as well. So
Before
without everything, it's just a pre that will load things from the file.
before we move on, Ollie is reminding me that we do have some Bytewax swag, and I was supposed to come up with really interesting ways to give that away, and I didn't have an opportunity to think of
No
interesting
pizza
ways.
jokes.
So whoever sends the best pizza joke in the chat, we'd love to, send us in a message your information, and then we can send you some swag.
Go.
That's it. Thanks.
Okay, so let me quickly share my screen so I can walk you through the next step, and I will introduce our next speaker because I want to spend a little bit more time afterwards. So based on this diagram, there's a couple things that we mentioned. Again, in this particular case, in this diagram, you will not see this order service. In this particular case, order service is just like emulates all these orders. But in the real life, you will have something like your RESTful web service and web API gateway or something like that that will be sending all the orders. To simplify this the complex diagram, so we decide not to include this in this particular bit. Now, so the reason why we need to have something like Apache Pinot here is multiple reasons, and one important reason is that when we land this data in the Kafka topics, it will look something like this. So when we look inside this enriched messages topic, we will see all these messages would look like this, but we cannot query Kafka easily. Kafka is the stream or log of events that pile up in kind of like continuously. Kafka doesn't have any concept of how you're going to be querying. Kafka has this concept of compacted topics where it will only store the latest and greatest value. But in this case, you still will not be able to just simply querying this. Querying of the Kafka topic would be cumbersome. And for that matter, we can use there's multiple other technologies. Even Bytewax can be used this. So like you build the app inside your Flask or inside your whatever is the web framework is winning these days with Python, and you can have a library like Bytewax that will be reading data from Kafka topic and materialize it in some sort of dictionary that will be displayed on your screen. But you will not be able to do any querying, like arbitrary query. You still will be relying on the things with the either key value, or you will have some sort of like a latest and greatest value for a particular key. So you have an option to move this data to your, either OLAP database or your OLTP database. So same thing we can use there's the concept of Kafka connector. We can dump this enriched topic inside the database. And after that, you will be able to query this database. So we use Kafka to do enrichment. And in this particular case, you can even say that like why I would need to use Kafka stuff. I can do everything in MySQL. Right. So this is kind of like a very valid question, like why to do all these things. I have my orders, and I have my the products, and I will run the join, and I will have the enriched orders, and I will just display this on the screen. And this is where the Pinot comes into play, because again, what would be fun if we're not going to be using the system that is a web scale for using this super over-engineered demo. So this is where we're going to be using the Pinot into play. So Apache Pinot, it's the open source project. It's just what's called the real time. I'll talk a little bit about real time, and for the purists out there, I will try to define the real time. It's a distributed database designed to serve the OLAP, the analytical workloads, and it can be integrated with streaming data. So this fits in our use case perfectly, with low latency, meaning that from the time when the event happened to the time where we can use this data in the query, we'll have a millisecond latency. So this is something like a real the most real-time thing that we have is milliseconds. It's not the system that you will usually put into kind of, I don't know, the system that will be getting data for controlling robots that performing surgery. So not that time real time, but the tens of milliseconds, it's a real time enough in order to get the fresh data. And high concurrency is an important bit here, because the system like the Pinot will enable user facing analytics. And we're gonna the Caroline will show how the applications that would be used by real users can be built using simply just querying querying Pinot. And high concurrency, like high number of concurrent queries, will be important part here. So 3 pillars why the Pinot is used in many organizations, and it's used in many let's see. Oh, yep, perfect, full screen. The amount of time it takes to execute the query is very low, so the latency is very low. It's a distributed system, even though it's a distributed system, but it's designed in order to perform the queries very fast. There's different ways to perform these queries. There's different type of indexes that allow to speed up the query. Concurrency, it allows to multiple different use cases use one data store to perform different type of queries. And freshness is an important thing that that Zander's already mentioned with probably the best pizza jokes that you will hear today. It is much better to have fresh pizza than stale pizza. And when you think about the stale pizza, it's like when you're running some analytical workloads on some I don't know, days old data, like days old pizza. So design of the OLAP system is the focus on optimizing the storage for analytical queries, aggregations, all sorts of counts, all sorts of things that allows to perform the query. And it is heavily read workloads. So in order to ingest data with your traditional database, it's a transaction based. You need to perform your transactions and the high consistency of this data and things like that. You just need to write very fast. And also, since it's a transactional, so we there would be high requirements on how many operations you can perform this. You can do this in kind of in batches, even with the transactional databases, but the idea kind of like you do single insert statement. With the OLAP, you kind of like bringing data in either in the style of batch, so Pinot supports that. We have an example how this can be used, and we can also call the things in stream fashion. So the Pinot table supports absorbs from the streaming data source like Apache Kafka. So when in the time when data will arrive inside the Pinot, this data will be available for queries. So that's why freshness and the low latency between the ingestion and getting result is also very important component of the Pinot. So the Pinot data structured inside the tables, and I don't want to go with the slides. I want to quickly show how this would look inside the Pinot. So the Pinot comes with this like a nifty UI console. When you run the makefile has kind of like a run command that will run everything for you. When you run this, you need to have relatively beefy machine in order to run this, because the systems that that's designed to run those workloads, like they designed to be like very to perform those queries. It might take a while when you start to run this locally, if you have the 8 GB of RAM or less. It would be very struggle for this system to run, but it includes three components for Pinot. So it includes a zookeeper that will be responsible for storing some of the metadata for Pinot. It will require the controller that will be responsible for keeping health of the cluster, broker that will be where the queries will be executed, and the server that will be responsible for keeping with the storage. Also, we do have a command that will pre-provision some of the tables, and those tables would look something like this. So usually Pinot has a table definition that will include what type of the table. So in this particular case, we do have what we called a real-time table, because we're gonna be reading data from. Let me actually do bigger font. I feel like it might be. We deserve bigger font here. Yeah. Let me quickly check where we. Are we still there? So I see it's a little bit quiet. Let me see if I see everyone here. Yeah, I still see like 17 people here, and chat still is up. Okay, cool. So the one of the tables that we defined will be reading data from Kafka topics. So from the orders, we're gonna be defining this. And we do have another schema that will define how this table would look like. So in this particular case, the orders would look something like this. And there's a enriched topic that will be also reading the enriched orders topic, and everything will be written from Kafka topic. So the reason why the Pinot is capable enough to run the joins themselves, so we can actually have orders and products topic, and we can do join on the side of the Pinot. But it was not always the case, because Pinot recently changed the engine for running the queries, and now the joins are supported. And in my opinion, in my experience of the talking about those systems, build those systems, kind of have things that already available for consumption is easier to do on other side of things, even though it will potentially change the architecture. And so once we have those tables inside the Pinot. Like I mentioned earlier, it comes with this like a nifty console where we can browse what kind of tables available. And this is like real-time orders information from here. So let me run query. And if I'll do something like orders, let's see how many orders we have so far. So this is the generated data that comes from the data generator. So this is the number of orders that landed here. If I run this one more time, this number should change, in my opinion. It changed, and we can see inside, if I go to our orders topic, we can see approximately what's the size. Let's see. Configuration, I don't see it. Yeah, so the roughly 100,000. Let's see if we have a similar number. Yeah, we have a similar number from the Pinot. So data generated on the Kafka side, it will land inside the Pinot. And we also doing enrichment. If I'll just do count, freaking Grammarly, disappear, please. And if I'll do this, and also when I run this query, it run the number of enriched orders, but also the response time 2 milliseconds to run this query. So it run the aggregation because the data is already available for to run this in analytical fashion. We can get this immediately. Now, so it is not something that very, you usually expose this query console for your users and run some queries like for those of you who want to try this yourself, to run this in the console, you can find a folder called demo, and you can find different the commands that you can observe and see all these messages. If you want to see what goes inside the Kafka topic, you can use the kcat command, which is Kafka cat. You can see how the schema in the tables looks like. So let's get the most recently used product category. So we'll take the product category as a category with and get the count for the last 5 minutes. We can see what kind of like queries we're getting, what kind of like the product categories we're getting. So we have a side orders. You never buy the pizza without fries. Probably veggie pizza, non-veggie pizzas, pizza mania, pasta, beverages, and stuff like that. So that's very cool. Everything is very cool. I can run this query in this console, but it's more important when I was talking about user-facing analytics, that your users want to see this data. And this is where Oli already hinted this a bit. This is where this very nice dashboard comes into play. And I really want to pass the microphone to Caroline to talk about what makes it possible. Spoiler, Python integration, Python driver for Pinot, and awesome framework called Streamlit that allows to have these beautiful dashboards instead of like going to this like the weird looking the web console. We have very nice thing that you can play on your iPad. You can put this inside your conference room or somewhere in the hallway, and the people would know how you doing, because we can run these analytical queries about the revenue, how much was sold, how many orders per second we executed. So I'm stop sharing. I'll try to go over the questions in in the chat. Ollie, do we have any like a very good questions that might potentially have
We
on?
have really good jokes.
Oh, very good jokes. Okay, so because the Zander the announced that
Yeah.
there would be swag for best jokes.
Yeah. You should also announce something about your swag.
Victor, there was a question
Yes.
before you give out your swag. There was a question about how folks can join the Pinot Slack, and I said
Yes,
there's a
I
Star Tree
will.
Slack, but I don't
I
have a
will.
link.
Yes, I will share those link in a few seconds. So there's two slacks for if you don't have enough slacks in your life. So we do have a Pinot. It's like Apache Pinot, like the Apache is open source software foundation that hosts Pinot, and there's a company called Sartre that is contributing a lot to Apache Pinot, but also provides the best management service for Apache Pinot. And those two separate. So historically, don't ask me why. Historically, but it's the same people the answering the questions in the both slacks. Majority of the people who came from the open source stuff, they come to work for Startree, and or they are open source contributor working on big companies like LinkedIn, the Uber, specifically Uber Eats uses a lot of Pinot. And yes, I will post the Slack links in a second. Yep.
Great. Well, again, I'm Caroline Frasca. I work on developer relations and partnerships for Streamlit. Super excited to be here. I am really disappointed in myself because I didn't add any jokes to this presentation. And I also never thought of adding jokes to the code and comments. It's definitely something I'm going to do moving forward. So unfortunately, no jokes for you today, but really excited to give you an intro to Streamlit, and then I'm going to walk you through how this awesome pizza demo uses Streamlit. So let's get into it. So taking a step back, let's kind of set the scene here with the problem that Streamlit is solving. At a lot of companies, sharing data insights across teams is a super frustrating problem. And this is because the tools that data scientists are often most comfortable with, they're not necessarily easy to share with non-technical coworkers. I'm talking about Jupyter notebooks, Python scripts, you get the picture. So many of the tools that would actually be more user-friendly for you to share across teams, like a Flask app, for example, they're not super easy to build. They're definitely not easy to deploy. And suddenly your data science team is spending way too much time figuring out how to build and share an aesthetically pleasing data app when they really just want to spend more time on their core job on data science. So this is where Streamlit comes in. And basically, Streamlit is a faster way to build and share data apps. So for data scientists and for AI or ML engineers, Streamlit is an open source Python framework that delivers dynamic data apps with just a few lines of code. Streamlit's really intuitive syntax allows you to build really quickly and really easily super polished UIs. Streamlit apps are built in a language that typically most data scientists are already comfortable with, Python. Streamlit syntax is guessable, it's opinionated, and it's really user-friendly. So when you're working with Streamlit, there's no backend CSS, HTML, or JavaScript experience required. You can build data apps completely using Python. It's also ridiculously easy with Streamlit to add interactivity, layouts, and even themes to customize your Streamlit apps. Streamlit is immediately operational in your existing data-centric workflows, and this is because Streamlit is a Python framework. So it's already compatible with your favorite Python libraries such as Altair, PyTorch, Vega Lite, and obviously many, many more. But pretty much anything you can do with Python can also be done in a Streamlit app because it's really just a Python framework. Streamlit also works seamlessly with your favorite AI tools like Llama Index, Pinecone, Weaviate, OpenAI, and LangChain, and honestly, a ton more. Those are just a few. So you can head over to streamlit.io/generative AI for hands-on examples of AI apps using Streamlit. and to learn more about our integrations with these tools. But honestly, with a lot of them, again, they're just Python libraries or they have a Python wrapper. So there's a lot of the time not even a real integration needed. Streamlit's API is made up of what we call widgets, which basically encompass fully baked functionality that you can add to your app with just one line of code typically. So for example, if you want to add a text input box to your Streamlit app, it's as simple as writing st.text input and passing that function a string for the label of your text input box. And then when you want to retrieve the current value of that widget, there's no complicated getter or setter functions for the widget. All you have to do is reference the name that you've assigned the widget, and that's how you get the current value, which is one of my favorite parts of Streamlit because it just makes building out more complicated apps super simple. And once you have the basics of Streamlit mastered, there are tons of ways to take your apps to the next level. Multi-page apps are a great way to build those more complex apps with multiple sections. Features like st.columns and st.container make it really easy to organize your app's layout. And custom themes are a great way to control the colors and even some of the basic fonts that you're using in your app. And if you're itching to build even more custom functionality into your app, you can actually use JavaScript and HTML to build your own custom component, or use one of the many existing components that have been built by our community. And these basically extend the functionality of Streamlit's Python library even further, with things that folks kind of wish were in the library, and maybe at some point we end up building it, or things that are even beyond what we might build eventually, to even new and creative functionalities. The Streamlit Gallery is a really great place to get your hands on tons of public Streamlit apps. And a lot of these apps, the GitHub repos are public, so you can fork them or clone them and start building on your own. Streamlit is also used by some of the world's top data science groups. We actually just recently interviewed Dan Miller, who is a staff data scientist at Airbnb, and his team at Airbnb they're basically like super users of Streamlit. They've built pretty much 100 Streamlit apps internally. They built their own deployment system, and they shared a lot of really interesting details about why they find Streamlit so valuable. And in just a second, I'm going to play you a clip, which I'm hoping the audio will play from. But this clip does a really nice job of summarizing why so many data science teams find Streamlit extremely useful. So just let me know if this...
Also, the lingua franca of data science and machine learning tends to be Python or Jupyter notebooks. And I cannot share to an exec a Jupyter notebook and say, hey, look at this. I think that's probably true of pretty much any company, but you can definitely share a Streamlit app, a live Streamlit app with, someone in the less technical arm of your company, and they'll still be able to, again, that tangibility, being able to interact with it is super powerful.
So he really summarizes that idea that I was touching upon earlier of you want to be able to share data insights across your company. You don't want to be limited to sharing, something that is really like non-technical. You want to be able to build something really robust, but something that's user-friendly and something that non-technical users will still enjoy. And that's really where Streamlit fills in that gap. So once you've built your Streamlit app, you're probably going to want to share it with a friend, a coworker, or, if you're super proud of your app, you want to share it with everyone you've ever met. And luckily, there's a free and super easy way to deploy your app, and it's called Streamlit Community Cloud. It's run by Streamlit, and it allows you to deploy one private app and unlimited public apps for free. And deployment is super fast and simple. You just connect your GitHub account and select the repo that you want to deploy from. And then if you need additional private apps or resources beyond what Community Cloud provides for free, there are also a few options for that. With Snowflake, we have a hosted product called Streamlit in Snowflake, and that allows you to build apps on top of your Snowflake data and to deploy those apps on Snowflake infrastructure. And then Streamlit apps can also be deployed generally on almost any deployment platform. So a great place to learn more about this is our community deployment wiki and our forum, where community members have shared guides and tutorials on deploying Streamlit apps on a ton of different platforms. And one of the best parts about Streamlit is really our community. So we have a super active community forum, which is the best place to start if you're stuck or you have a question, or you're trying to run this demo after and you have a question about the Streamlit app. Definitely head on over to our forum at discuss.streamlit.io. Chances are someone has run into a similar problem in the past and can help you out there. Our creators program is another great part of our community, and it highlights community members who have set themselves apart through helping other users in our forum, building amazing apps, building custom components, and much more. So you can learn more about our community programs on our website there as well. And getting started with Streamlit is incredibly fast, incredibly easy. Just head over to the command line if you want to develop locally, pip install Streamlit, and then you can enter Streamlit hello to run an example Streamlit app. You can also get started with Community Cloud and our GitHub Codespaces integration. So if you really are like, I don't want to touch the command line, which I kind of understand, to be honest, you can develop completely in the browser there. So now that you know what Streamlit is, let's talk about how Streamlit is used in our pizza demo. So in this demo, Streamlit is obviously the interactive data app, the front end that's allowing you to actually look at all of the data, look at the tables of the most popular items, the most popular categories, the latest orders. We're also allowing our users to be able to select whether they want to auto refresh the app to reflect the latest data. They can adjust the refresh rate in seconds, and they can also choose the time period that they want to display data over. So if you want to look at the past 1 minute, the past 5 minutes, the past hour, etc. And then you're going to, as I mentioned, be able to view metrics based on that time period, the graphs, and all of the tables.
And I don't know if, Caroline, you're going to mention this, but I believe this is that the built-in feature in Streamlit that you actually can record a screencast out of the app.
This GIF is not, but you definitely can do that in Community Cloud. There's a built-in feature to record a
that's a very cool thing.
So just to break it down, I want to walk you through the different features that we're using here. So we've got like a little doodle here just to kind of show you what features are being used in each part. But starting at the top, the features doing really like the heavy lifting here are st.plotly chart, st.data editor, st.metric, and st.container. Those are really the main players here, but we're also using info, expander, toggle, number input, radio, and title. So really a ton of different features here. I'm going to walk you through some of the main features that we're using and how we're using them, and then I'll run through the code at the end, but I just want to take you a little bit deeper on some of these features. So one of the primary features we're using is data editor, as I mentioned, and it allows you to display pandas data frames, but also a ton of other data structures like NumPy arrays, PySpark data frames, Snowpark data frames, in this really nice table-like UI, where you can also optionally allow users to edit the table. And so that has been like a super highly requested feature for Streamlit for several years. That we haven't been around for that many years, but for a lot of the years that we've been around. So this is one of my personally favorite features. And one important part of data editor is called column config. And so you can basically use this configuration. It's a suite of methods to tailor your columns to various data types. So ranging from really simple text and numbers to lists, URLs, images, and more. You can see some of the example different data types that we support here. So really it allows you to format things in a super user-friendly way, rather than just, having that data thrown in there with like a standard table, but you can actually do a select box column. You can see this example here where if you wanted to like allow people to, go through a couple different options and pick an option, and then you wanted to like write that data back to your database, that's a super powerful feature. So yeah, again, really just prioritizing formatting your data in a user-friendly way, a really visually appealing way. And we're using this in the Pizza demo app specifically to make sure that our numerical columns and our image columns are really displayed optimally. And then the next feature I want to talk about is st.pyplot. This is a pretty basic feature. We're really just displaying a matplotlib pyplot figure, but this comes into play with showing the charts for the orders per second and the revenue per second. That's possible because of st.pyplot. So that's definitely a major ingredient. I'll just try to ad-lib some puns because this presentation is seriously lacking in the pun department. But st.metric is another big player here. So this is really a great function if you're building out that kind of analytics, classic data analytics dashboard like the pizza example. And this method allows you to display a metric in really big, bold font, and you can optionally display a delta indicator, so you can show how the metric has changed. We're doing that in the pizza example as well. And st.metric really looks nice in combination with our columns feature, which allows you to display the metrics side by side. And that's what we're doing in the pizza example too. So you can see an example of that below too. Finally, this is more of a UI feature, but it is really important in the dashboard because in this dashboard, we've got kind of these classic like cards that are encircling all of the, the charts, the tables, the different parts of the dashboard. And that's also kind of a commonly requested, has been a commonly requested feature for a while, so that you can build that classic data analytics dashboard with the separation between the different sections. And basically st.container creates what's usually an invisible container in your app that you can add multiple elements into. But in this case, we are using the border parameter to display a really thin border around each container, which again gives you that card look that a lot of classic data analytics dashboards are looking for. So as I mentioned, there are also other features that we're using in this demo. st.info is used to create this lovely little call out section here to let you know the last time that we updated the dashboard. We're also using st.expander to create a section with the dashboard settings that can be completely collapsed, so that if you've already configured your settings, you don't want to look at it anymore, you can hide it super easily. st.toggle is a great way to allow users to configure a binary setting. So in this case, you can set auto-fresh to be either on or off. And st.number input allows you to adjust the refresh rate and set it in seconds. And then finally, st.radio is being used to configure the time period over which you want to display data from. So one other part of Streamlit that I want to touch on with the goal of explaining how we handle this part of Streamlit in this demo is Streamlit's execution model. Streamlit has a pretty unique execution model where basically anytime that something needs to be updated on the screen, your entire Python script reruns from top to bottom. This model is really helpful for a lot of use cases, largely because it allows you to avoid event handling logic that a lot of other frameworks you would have to deal with. It's kind of a pain, honestly, so you don't have to deal with that with Streamlit. But there definitely are use cases where you're going to want to modify this execution model. And luckily, we provide multiple different ways that you can go about this, that you can kind of handle the execution model. And I'm going to run through some of them pretty quickly. But but Streamlit's caching methods are one way to do that. So we have two caching methods, cache data and cache resource, and they allow you to store the results of slow function calls so that you only need to run those functions once, which obviously ends up making your app faster, but it can also help you persist objects across reruns. And then Streamlit also has a method to rerun the script entirely called st.rerun, and a method to stop the execution completely of the script called st.stop. And then session state is a way that you can share variables across reruns of your Streamlit app for each user session. So that's another way that you can persist information across reruns of the app. And coming soon, actually, we have a really exciting feature that has also been a long time feature request in our community called partial reruns. And this feature will allow you to turn any function into a Streamlit container that runs independently of the wider page, the wider Streamlit app. So in the future, we would implement this demo using partial reruns, but for now, we're using a workaround that I want to explain a little bit further. So how does this app handle Streamlit's execution model? In this demo, when you click the auto refresh toggle, an item in session state, that feature I just mentioned that allows you to persist values across reruns, it gets set to true. So auto refresh is true. And then at the very end of the script, we check the value of auto refresh. And if that's true, then we delay the execution depending on what the user has configured the auto refresh rate to be. So, if it's 2 seconds, wait 2 seconds. And then we use that other feature I mentioned, st.rerun, to rerun the whole app. So when you rerun the entire app, we'll get new data, everything will update, we'll update the time that it's been up. This app has we've last pulled data at this time. And so that's basically how we are getting this real-time analytics dashboard. But in the future, you would be able to implement this with partial reruns. So now that you hopefully understand what's going on behind the scenes of this app, how could you also take this app to the next level? There are two major opportunities that I see with this demo if you wanted to expand it. Data editor, obviously, based on its name, allows you to build editable tables. So one area you could definitely implement would be allowing users to edit the tables and then writing that edited data back to the source. So for example, maybe your users want to edit the status of the pizza order. So just to reflect, oh, I've shipped this pizza order. So you could add, that nice looking multi-select of shipped, confirmed, etc. And as I mentioned before, the other opportunity would be using partial reruns to make this live aspect more natively integrated. And it will make the process of controlling the reruns of your app a lot smoother. So shameless plug, this feature is in private preview. If you're interested, go check it out in our forum, play around with it. We're still collecting feedback on it, so we'd love input. I'm going to switch to sharing VS Code for a second, and then I'm just going to walk through the app overall. I'm not going to go into super great detail, mostly because it would be a little bit boring because I didn't add pizza jokes in the comments, but just to give you the overall.
There were, while you're getting sorted, there were a couple questions around the different open source projects that do similar things, namely Shiny and Dash to Streamlit. So maybe you can tackle that one as well. I sent something I found on the internet, but I'm sure you have a better answer.
Yeah, there are a couple of different competitors. Obviously, I'm biased. I love Streamlit. I think that I'll respond to that in the comments because this is a longer answer. It really the shorter answer is that it really depends on what you're looking to do. And Streamlit is really excellent for that use case of you want to enable your data team to build really polished looking data apps quickly and share them across your company, as well as the AI ML use case. But yeah, I can also give more details on that in the comments. So yeah, just to walk through this app, Not gonna go through
Can
every
you
line.
can you make a font a little bit bigger?
Yes. Is
Hate to
that
do this, but someone has to.
is that good? Can you,
It's perfect.
is it okay? Cool. So obviously setting up the Pinot host, Pinot port, all that jazz, setting up the title of your app. This is where we are displaying when the app was last updated. So as I mentioned, it's updated every time you rerun the app. So we're getting the current time and date right here. And I'll show you how that works at the bottom as well. But this is where we are initializing session state. So we're checking to see if this sleep time value is in session state. And if it's not, we're adding it and we're setting that equal to 5. We're just going to assume that people want to auto refresh this dashboard to get started. So we're adding that to session state as well. This is where we're setting up mappings of the different options that we're giving people for the time period that you can view the data over, which is obviously, an hour, 30 minutes, etc. But basically setting up mappings so that these time periods are in the format that we need them to be to pass that, to query the database, essentially.
Yeah, so this is something related to Pinot. It is the things that will be parsed by the functions when we're passing this. If we need to have a different time, the like past like 6 time ago since last like 60 minutes, something like that.
Yeah, cool. So this is our expander where we've got all the dashboard settings, and we're setting them up in 2 columns. You can see right here in the left column, we've got that auto refresh toggle, which again is connected to that session state value for auto refresh. And then we also have the number input for the actual refresh rate. And then on the right side, we've got that radio option that I mentioned, where we're going to give people the different time periods over which they can view data. And then, setting up the cursor to actually run your queries. We've got a try except statement where we're actually running our first query with some nice exception handling. And then finally, here's another query that we're going to be running, and you can see this is really nice how this is going to update based on what the user has selected. This first section is displaying orders in the last, whatever time period you selected. So once we have the results, once the query has been executed, that is in a pandas data frame, and we set up, as I mentioned, containers are everywhere in this app because we're using them to create the nice little card section. So you can see we're setting up a Streamlit st.doc container here with that border equal to true, and then adding our title orders in the last whatever time period you selected. And then for the actual metrics that we're going to display, again, we're going to display them in the 3 columns side by side. So that's what we're doing here. And then we're actually just adding the st.metric elements to show the number of orders and the revenue, and then finally the average order value right here. So all of that logic is going towards setting up that lovely 3 metric layout that you saw. And then finally going to the next query, again, returning a pandas data frame. And I don't know, Victor, if you want to talk a little bit about some of the stuff that you did here, but I feel like a summary is that you're kind of setting up the data into a format where we can show a Plotly chart of the revenue, and then I think it is the orders.
Yep.
Yeah.
Yeah, so there's a lot of kind of repetitive things to get the data, to massage it and turn it into something that can be displayed. And after that, we put this inside the poly chart plotly chart.
Exactly. So we're doing some similar things here in the column to the right that's showing the plotly chart of all the revenue. And then we, again, more columns, more containers and columns everywhere. And then we are going to display that data editor table with the latest orders that were returned from that query there. And you can see we're using the column config feature that I mentioned to nicely format some of these things. These are numbers, just regular integers pretty much. And then in the right-hand column of this setup, we have the table that's displaying the most popular categories of orders. So again, doing something super similar, setting up a data editor, passing that the pandas data frame, using column config to nicely format all of the columns. No really crazy columns here. You could add, you know, again, if you wanted to write back to your data source, you could add some multi-selects of, I don't know, what other like pizza related things you might do. And then towards the end here, we've got that larger table with the most popular items. This one, we actually finally have a column that is a little bit different. We've got the images of each item, which I thought was really fun. But again, we've got that container set up with the lovely border around it, the data editor table where we're displaying all of that. And then finally, at the end, this is the section that I was mentioning earlier, where we're checking session state to check the value of auto refresh. And if that's true, we're going to sleep for the number of seconds that the user specified as the auto refresh rate. And then we're going to rerun the whole app. And that's our mechanism to update the app. Cool. So
Thank you so much, Caroline.
Yeah, that is all I had. And I will turn it back to Viktor.
I will close the how you call it, the lid of the box or the pizza box. You know how you prepare this. Now you need to the packet and tender to the delivery person and or like to the person who to order the pizza and things like that. So yeah. For those of you who wants to run everything by yourself, the couple of things I just want to once again bring this picture into the play. Where is it? My Excel draw. Actually, this is the fantastic version of the Excel draw that Ollie drew, and thank you so much for this as well. So once again, I hope after the things that Zander and Caroline will talk about, and hopefully yours truly, you got the little bit idea about the more or less complex data pipeline. Can it also be achieved with the MySQL instance? Yes. Will it be a scalable solution for some like complex problem? Probably not. Should you start thinking about those things earlier? Also, premature optimization is the sin of many engineers. However, in this solution, we wanted to demonstrate the complex data processing or data pipeline design that you might encounter in your real life. I don't know what's the experience of the group in terms of like implementing those systems or supporting the similar kind of pipelines, or just like using this for educational purpose. So those things, the multiple different components of all these demos can be replaced. For example, we're using, in this particular case, we're using the official Python library for Apache Pinot. Integrates with Pinot, and that's why we were able to very easy. I want to emphasize this point that Caroline made, that since the Streamlit is the Pinot, the framework, so any libraries can be easily used. So there's no problem to connect to the system. So if you have any other analytical database you want to swap, if it has a the Python driver, it can be easily used for this. For my Java friends, we do have a Java JDBC driver and some Java API, and we also have some experimental native Golang clients for Apache Pinot. So yes, some of the components can be replaced. For example, I know that many people are looking to implement their systems using not Kafka, maybe something like Apache Pulsar or something with um, uh, the Kinesis in AWS or something like that. So it also can be used in this particular situation. The Pinot has the connectors to Pulsar. I hope the Bytewax also has the connection to Pulsar. Zander, do you have the connection to Pulsar?
Well, we can use the Pulsar has the Kafka API
Oh,
compatible.
yes, like
It's
silly
not
me,
fully
exactly.
compatible though,
Yes,
so there are some
yes.
subtleties there
So
because it requires acknowledgement. And that's actually something in Bytewax you can't do exactly once processing for the acknowledgement today, but in the next big release, we'll have two-phase commits, so you can do exactly once, guarantees for act-based sources and syncs too that require that for transactions.
yeah, that's very cool. I forgot that Pulsar has a Kafka interoperability layer. Um, and so the things what the Caroline mentioned with the kind of like after refresh app and things like that. So it's also not a problem for the Pinot. So it will not be hammered by the app refreshes and things like that. In real world scenario, you probably need to maybe figure out the way how your front end will be reaching to this database. But we do have examples where like we're running like 100,000 queries per minute, and the Pinot still running. As a matter of fact, I was surprised. I usually I don't like to brag about the kind of like use cases, but since we mentioned that the Uber, and I mentioned Uber without a joke, so the Uber actually uses for restaurant manager in Uber Eats. So every restaurant who the connected to Uber system, they see what is going on with the orders. They use Pinot. Also, the every time when you open your Facebook and you see notification somebody saw your profile, this analytics was the first use case how the Pinot was developed and introduced. And after that, multiple we spoke with Oli today about the cool feature of analytical feature of following some of the competitors on the LinkedIn. This feature is also built on top of Apache Pinot. And this is super cool. If you're interested in this type of jazz, we are planning to do a real-time analytics summit that's going to be later in May. You can find information on our realtimertasummit.com, or if you're interested to come, write me DM on Twitter. I will find you a friends and family discount if you really want to come and learn about like real-time analytics and stuff. So with this, you all have a GitHub link. This GitHub link is not going anywhere. Not this one, this one.
So there is a great question actually about how
Please.
you would deploy this demo in production.
You just like get the beefy instance on AWS and run Docker Compose, and this is how you win the I'm kidding. So there's multiple aspects. The reason why we have those, let me kill the screen for now. I just because, yeah. So there's multiple different aspects of how you would run those in production. I do have a. Can I call it PTSD? No, I don't. I love to run everything in Kubernetes. Like Kubernetes is probably the best way to build a platform these days. Kubernetes is not the end of the game. Kubernetes is something that you start and you build in platform on top of it, and the containerized the applications, containerized workloads will be naturally easy to run inside the Kubernetes. In the Pinot, we do have a support for running the Pinot components using Helm chart inside the Kubernetes. Every application that we have here, Streamlit application, the Bytewax application, are Dockerized. So you can build those images, push to your Docker repository, and after that, deploy this into Kubernetes. This is how I would do this. If you ask in a kind of like advice from from the person with the Kubernetes PTSD. I love this system. The managed service is definitely for help. Caroline mentioned that Streamlit has managed service. I mentioned that we at the Star Tree we have a managed service for Apache Pinot. The I'm sure Zander and Oli brewing something in the Bytewax to have this also on the managed service side of things. And I don't know actually if you planning to do something.
We don't have a managed service. We have a self-hosted platform that we recommend for when you're deploying multiple workloads to production, but it's not 100% necessary to use. It just helps scale disaster recovery, authentication and stuff like that.
Yeah. So I think in certain senses, Kubernetes would be the best, but I would not recommend to make any stateful workloads like database or Kafka server or Pinot your first project. It definitely has a learning curve. So teach yourself how you can run stateful workloads like web apps and things like that. Get develop this muscle of deploying this stuff in Kubernetes. There's definitely other choices. You can definitely run this as a in AWS. There's plenty of different tools available. But yeah, like things are much easier and much simpler when you have it containerized versions, and you have a Docker Compose, you have a Docker files. It can be easily turned into Kubernetes deployment. This is I would do. I don't know, like if you folks have other ideas.
Is it actually recommended to deploy Pinot on Kubernetes, or is there a different, like for best latency, for best resiliency, is that the recommended practice? Because
yeah, recommended practice is to run this in the Star Trek Cloud. I'm just kidding. So it really doesn't matter. It really doesn't matter what kind of it's all about it's a tool. It's just a tool that allows you to do this, and that's why I mentioned this. Don't make it as your first project to run Pinot in Kubernetes, because if you don't know how to manage storage in Kubernetes, how to make the backups, probably it's okay. It's not. It's an analytical data store. You can lose some data, and after that, rehydrate this on or reload this from some sort of sources. Probably it's not the place where you can store all your precious data. But if you run Kafka in Kubernetes and you lose the data, this is the different story. And that those systems right now have a lot of expertise in the world to run this in Kubernetes. There's different knobs that can be turned around in terms of what to run, what not to run in Kubernetes and things like that. But in general, it's quite all right to run Kubernetes. To be honest, our own platform, Star Trek Cloud, it's Kubernetes internally. We wrote a lot of kind of like automations around this, but it is. If you use Docker and Kubernetes, how do you think about collocating or not collocating different components there? So you don't have much of the control except some sort of tolerations when you deploy things in the Kubernetes. You just will be relying on the way how different nodes will be placed inside the Kubernetes cluster. You can hint to Kubernetes to do certain things, like with daemon sets, with the stateful sets, and all these kind of things. Yeah, just like we do have some documentation around the production deployments and like what kind of recommendations we have there. So those information available on the Pinot website and dev.startree.ai. Reference architecture. So I don't have it on top of my head, but like if you join the Pinot Slack, definitely we will be able to share something with you. I'm pretty sure that we do have it somewhere. I just don't want to like spend the time right now Googling, but this is a very good question to some of the things to have in the future. Yeah, so we do have the on the Pinot website. There's a configuration recommendation, different knobs and turns that you will be able to configure.
Yeah. So thank you so much, everyone, for attending, and thank you for your questions. Again, I'm posting the link where you can find everything, the GitHub repo, the Slack, and also we will be posting the videos shortly. So you can find them on our YouTube and through social medias. And I hope we'll build more exciting things with streaming technologies and Streamlit. And see you again for other workshops. Thank you.